Hi guys, sorry I can't be in school again to teach you, but I've made a couple of videos here today to talk about this next part of trig graphs, okay, and it's talking about what's called a phase angle, okay, and before I go to the notes, I wanted to show you this kind of program, the GeoGebra program, where you can manipulate this kind of angle to show you kind of what it looks like when we do that. So as it kind of states in your notes, I want you to think about this in terms, the same way we thought of with quadratic graphs when we had something like x minus 1 squared or x plus 5 squared. When there was a number put inside the bracket with x, it affected the horizontal direction. It moved the graph either left or right. Okay, and you're going to see a similar thing happen here with our trig graphs. So what we've got here is we're starting with just a straightforward f of x equals sine x. And this slider up at the top here is going to either add or subtract a phase angle, basically. And what that's going to do is it's going to move the thing either left or right. So I'm just going to slide this along just a tiny bit, and you'll see I'm now at x minus 30, okay? And I'm just going to slowly start again back from 0 and then slide it along to the right hand side. This is going to be x minus the angle, just to give you an idea of what happens. So okay, so I'm now at x sine of x minus 180 degrees, and you can see that the whole graph has been essentially shifted to the right by 180 degrees. Now, the reason that we don't see the rest of the graph is because our range is only between 0 and 360 here. So where our graph started is now starting at 180 degrees, and the end of the previous wave has actually now came into our range. So this is why we get this kind of minimum turning point section here from 0 to 180, because remember, the sine graph, it's not just one graph isolated, it's an infinite repeating graph that continues as a wave. So if I kind of go back to 0, you can see that our starting point, which is currently at 180, should go back to where we expect the sine curve to start, at 0. Okay, and we're back to our sine x graph. Okay, so if I can just mark on this second function here, which is just another sine curve, that is showing you what sine of x minus 30 is. So that minus 30 means that the graph that curve does not start at 0 anymore, it starts at 30 degrees. The maximum of that sine curve is no longer at 90 degrees, it's 30 degrees to the right, so that would be at 120 degrees. Okay, so everything has just moved 30 degrees to the right, essentially, okay? And if we go the opposite way, which is going to be x plus our number, you should be able to see that the graph starts going left. Okay, so if I go all the way to x plus 180, it's actually a very similar graph. The kind of maximum half has been chopped out of view this time because it's left of 0. We've still got the sort of minimum area there, but the maximum of the next wave has now been brought to the left, which is now within our range. So actually, the graphs of sine of x plus 180 and x minus 180 are actually exactly the same, because this is just a repeating graph, because the graph repeats every 360 degrees. So if we add 80 and take away 80, the distance between those is 360. So basically that's just one full wave. And if I just sort of simulate this going forward and back, it should give you that impression of a continuous wave, which is what these trig functions are, okay? So going back to our starting point where a is 0, if I can get it there. Fundamental part of this is just to show you that g of x, if I put it back on, that's x minus 30. Everything moves 30 degrees to the right. If I put on this third wave, that is x plus 30, and what's happened is we've moved everything 30 degrees to the left. Okay, so just remember, the minus in the bracket means it goes right, the plus means it goes left. It's kind of opposite of what you think. Okay, so the minus goes right, the plus goes left. Okay, so that's it for this video. I just wanted to show you that quickly before going on to the notes. So you should now watch the video lesson of me going through the phase angle notes.